I'll say something in Romanian now for our teams. Bună ziua, ne aflăm la prima sesiune de webinar tehnic.
Bună ziua!
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 Bună ziua! Bună ziua!
O să rog echipele românești, așa cum v-am spus în chat, obișnuiți-vă cu acest chat să postați întrebări. Vă rog să vă redenumiți fereastra cu numărul echipei și prenumele, astfel încât Mac și Emily să poată să vă identifice când adresați întrebări. And now, Mac, you...
All right, awesome.
You
Hi,
are
everybody.
the co-host, and you can share with us what you have for today. I'll be here to allow the others who are waiting in the waiting room, and when the 100 participants is covered, that's it.
All right, so then let's kind of get started here. Let's see here. Minimize that. And so, as Anna mentioned, my name is Mac. I'm from Rev Robotics. I'm a customer success manager here. So basically, my role is kind of like take care of and write a lot of our documentation. So that's one of the big things that I kind of work on. So helping teams kind of get through the control system and other programs is kind of what I kind of do here, working with our engineering team to make sure that we're able to kind of get kind of a lot of our products supported and make sure that folks kind of know what is kind of going on. I've been involved in FIRST since I was in high school, which was about 15, 16 years ago. So it's been a while. I've been a coach, a mentor, and a volunteer. So with that, we have a lot of our folks here at Rev also have similar experience like that. So we bring a lot of general FIRST experience to the programs and trying to kind of create things that make the experience of doing competitive robotics a little bit easier for people here in the United States, but all across the globe. We've really seen that FIRST has had a huge impact on our lives, and being able to have access to these programs has. And so whatever we're able to do to kind of do, help grow these programs is kind of something that is more or less the mission of the organization. So with that kind of in mind, one of the big things is actually your robot controller. It's probably the most expensive piece of equipment that is going to be on your robot itself, as an individual unit. And so a lot of teams are utilizing the ControlHub within the First Tech Challenge program. I know Romania was one of the regions that was using it in beta. So some of you may already have a lot of experience with the ControlHub. But this is kind of to give a little bit of an overview of what the ControlHub is, and then kind of being able to move from there. I have a little bit of a tech demo with some of our new software that we have that's available for Windows PCs. And also going to try to highlight some of the changes that we have in our documentation so that you all can find some of the information that might make your robot perform a little bit better. So with that in mind, let's kind of get started here. We're going to get started by kind of looking at the control system kind of in the past and how it has kind of like moved forward. I kind of find context, being able to know where things have been to be really, really important, especially in engineering design cycles, because it's one of these things where you can kind of take within your team, right? You're building a robot for this game or for a series of different games, and you learn new things with every game that you play or with every single robot that you build. And then you take those things that you learn and you put them back to be able to make a better robot. That same process is actually happening here at Rev with a lot of our products, but it actually has happened with the system as a whole. So if you go really far back in time, so we're talking like 2007, 2008, 2009, the first tech challenge program started by using a product from Lego called the NXT, which some of you may be familiar with if you participated in the first Lego League. They have like an EV3 variant is the next generation of that controller that was utilizing with a Samantha module. So it was a custom Wi-Fi controller that was created by FIRST for the control of these robots. And around 2015, there was a migration going from that to an Android controller with an Android phone that would do a couple of different things a little bit better. So one of them was like on the event side, you used to have to bring in Wi-Fi routers and game pads and switches and computers and all these other things that have to be physical event infrastructure that would have to be set up by an affiliate partner. So like Anna would have to haul all this extra stuff to an event and have it all get set up for that event to be able to run. And then also that experience wasn't really the same thing as what you were doing at home in your own lab or your own shop. So with the switch over to Android devices, you're able to do a Wi-Fi direct. So it was a point-to-point system. You're able to start doing Sports Start, which is the competitive model that we kind of run under now. And you can end up making things a little bit cheaper because you would be using cell phones that were commercially available. And this had kind of a number of positives that were kind of moving into the right area. And this was with another control system that had a bunch of different modules. So there were like motor control modules, a power supply module, and a few others that would kind of exist and get sprinkled across the robot. This was kind of similar to what was happening with the NXT controller, because that controller itself also had a number of other little modules that would end up powering servos and DC motors and et cetera, with the NXT just kind of functioning as input for sensors and also kind of as the robot's brain, for a lack of a better analogy. But as we kind of get moving in, you kind of have a couple of things are kind of happening simultaneously. So you have the first global program is happening which has the version 0 of the control hub and the expansion hub as a pair mate for that device. And then in the first tech challenge world, the expansion hub gets picked up and being able to be used with the Android controller. So some of the benefits of using the expansion hub over the previous control system there was, there was a lot of locking connectors. There was less USB connections. There was only one connection that was over USB to an expansion hub. So that was a large scale positive. So it kind of was able to round out some of the rougher parts of the first generation of the point-to-point control system. But in reality, it was really actually designed with the control hub in mind. So you would be able to have the control hub connecting to an expansion hub. You would have an embedded robot controller, so you would have better I/O connectivity. So basically there's two boards in the control hub. One that kind of functions as like your Android robot controller, and the other one is basically an expansion hub. So there's no USB connection between these two. It's a physical connection, which then makes it a lot less likely for it to have a disconnect and a lot less likely to have that failure. It's a little bit easier to be able to use a commercial off-the-shelf webcam. So if you're using a UVC webcam over USB, which is a lot of U's and acronyms all kind of jammed in together, but it can plug in natively to the control hub, which made things a little bit better. But one of the things that we kind of learned with the version 0 of the control hub was a few things mainly around Wi-Fi control and kind of how that top board was developed. So the top board on the Control Hub V0 versus the Control Hub V1, which is basically the present Control Hub itself, with the part number 1590 as the last four is 1595. That's the unit that was used last year for the First Tech Challenge program. It was used for the beta there. It does the full rollout this year for 2020 for First Tech Challenge, and has also been used in First Global for 2019. So one of the things that I like to tell folks is like, we have run the Control Hub at an event with this version of the Control Hub has ran at events with about somewhere between 160 to 190 teams participating all simultaneously, with having very little communication issues with the previous version of the Control Hub all the way through the most modern one. The last First Global event that we ran was running all with our Control Hub and expansion hubs being ran through them. And we were looking at having extremely low ping times. So the communication between your driver station, so the inputs that you're putting in with your controller and the robot itself was really, really low. So it was able to facilitate that communication a lot better. And so there's a number of these things where it has been a little bit of field tested also by teams like, for example, in Romania, right? You guys have used this previously. So it is at the point where it is relatively mature in the life cycle of a robot controller. One of the things to kind of keep in mind first before you're even getting started is some of the specs of the device itself. So there isn't, as I mentioned earlier, there is a custom circuit board that's running Android on the top of, basically on top of an expansion hub that's sitting inside of the board. It is compatible with your expansion hub, so you're able to use it downstream, connected for over RS-485. So the same way that if you were using an additional expansion hub in the past, you now just replace your expansion hub that had the robot controller would then just get replaced with a control hub, and you can still communicate downstream to an expansion hub. So you can get the additional motors and sensors and servos that way. The physical footprint is the same. It's still a 12-volt device. One thing that you kind of do need to keep in mind, though, is you have a single battery that is powering both the control hub and the expansion hub. So if you are designing mechanisms that have a lot of power draw and you're on a battery that has maybe already gone through a match or two, you may see that the control hub itself could brown out. And basically what that does is it causes the control hub basically to reboot. This is something that doesn't really happen too frequently, but if you end up having like a robot that's running, a multi-articulated arm, right, that has, 4 drive motors, and you're running on a battery that has like about maybe 10 or 12, like 10 or 11 volts left in the tank, from your readout, likely the voltage is going to dip low enough that it would cause a brownout condition on the control hub. So that's just one of the things that you kind of have to keep in mind, where with the robot controller phone, you didn't have that problem, basically, because there was an integrated battery in the robot controller. So as long as that was charged, you might not be able to get the power out of your motors, and the expansion hub itself would actually brown out at around 8 volts. So there's some of these things where you just kind of have to kind of keep in mind where when you're kind of designing mechanisms with what your power bands are and things along those lines. But when you're looking at the rest of the device, your sensor ports are all the same. So you still have, your 2 analog, you have the 4 physical digital ports, you have the I2C buses, you have 4 of those, you still have the RS-485, you still have the encoder ports. So all that stuff kind of stays the same. And you also still have the internal IMU that is inside of the control hub itself. So it already does also come with an internal sensor that you can utilize with the encoders that are in your motor to be able to do some basic, well, it's not really basic, but getting more towards the advanced levels of programming where you're able to utilize the IMU to know, for example, like your heading, and you can use the encoders to know roughly how far you've traveled on any individual field. As I kind of mentioned previously, these are kind of some of the ports, but on this image that we have in the bottom right here is actually the back of the control hub itself. One of the things you'll notice that is still the same is you still have the mini USB port. So that's mainly for connecting with that bottom board, the expansion hub that is in there. But you also have a couple of these USB ports, the USB-As, that can be utilized with your webcam. You're able to plug those in directly, and you kind of don't run into very many issues with trying to figure out how to do like a custom wiring harness to provide power to the webcam and all these other different types of things. There's a USB-C port. So this is the primary way that you would connect over USB-C to connect it to a laptop to be able to do those types of connections. There's also an HDMI and a micro SD card slot. The HDMI, you're actually able to plug into it and see the screen of the control hub. So it would look fairly similar to that of what your robot controller phone does currently. And the micro SD slot, one of the things that we have that we're able to do with that is it allows us to do updates to the top board of the control hub and the bottom board of the control hub when folks might not have access to the internet is actually really the main reason why. So for example, we're a proud supporter of FIRST programs all across the globe, including the one FIRST Global. And sometimes, it's a little bit difficult to maybe get a strong internet access in some really remote areas, some smaller islands, et cetera. Some of these things can be a little challenge if things happen to go out, so we can be able to ship or mail things a little bit easier. So that's one kind of positive with the ControlHub, is that you're able to field upgrade the operating system, the robot controller app, and even the firmware of the device remotely. So that's kind of cool. All right, so one of the big things that's kind of important to kind of look at when you start trying to figure out where the ControlHub kind of fits within a universe. So this is kind of our kitchen sink wiring diagram. So it's basically every device that Rev sells, for the most part, that is utilized within FTC is somewhere on this wiring diagram. So if you're looking at connecting, you're able to connect your ControlHub, right, can get connected to another expansion hub. You have your motor and encoder ports are all on the left side of your ControlHub or expansion hub. You have your servo ports that are on the bottom. So if you're looking at getting additional motors, you can potentially use something like a Spark Mini. If you're looking at getting a number of them, you're probably going to want to use an expansion hub. But you're able to connect a Blinken. You're able to connect your sensors through the sensor ports, like whether it's a color sensor or a touch sensor or a potentiometer. And this is just generally speaking kind of how things can get laid out, and you're able to kind of run anything off of these devices. So this is going to look fairly similar if you were to have done a full wiring diagram of a 2 expansion hub robot. This is a fairly similar diagram to that. The one major difference is that you don't have a connection that's coming out of the ControlHub to go to some Android device that is kind of floating somewhere on your robot itself. So that's just the one thing that you really need to kind of keep in mind. Some of the big things that have been improvements with the ControlHub. So some of these have been even more improved since we've released another version of the operating system, but the really big one is actually going to be your connectivity with your driver stations. So the ControlHub itself is a device that's able to use both 2.4 gigahertz and 5 gigahertz Wi-Fi. And we're also able to have a little bit more direct control through the operating system of the ControlHub's Wi-Fi behavior. So to give a really kind of like high level basic overview, Wi-Fi Direct basically functions a little bit more closely to that of like Bluetooth or something else. So it's still using Wi-Fi, it still uses that frequency, but basically you have 2 devices and they kind of have a little bit of a handshake, and then they agree that they're able to talk to each other. One of them will turn into the host, and the other one basically is a client within that relationship. With the ControlHub, it kind of functions a little bit more like your home internet router. So if you were to go to or at school or at a place of business, where it generates a broadcast network that then you basically log into that broadcast network. So you create a password and a SSID or the name for the ControlHub itself, and then you're able to connect in that way. With Wi-Fi Direct, you could still do dual band to some degree, but with the access point, we're able to kind of change some of the behaviors of the access point, which then basically makes it where it's a more reliable connection, not only for you, but for the more people that are at an event. It will make it more reliable for everybody, basically. So the more people that are at an event that are running a ControlHub, the better experience they're all going to have. One of our big recommendations is that if you have a driver station Android device that is able to do 5 gigahertz, to switch to a 5 gigahertz channel. And the main reason for this is that here in the States and even internationally, there is basically somewhere between 11 and 13 channels that you're able to operate on the 2.4 gigahertz band, right? And there's overlap between those channels. So if you happen to have a bunch of people on channel, let's say 3, right? And channel 3 is overfilling, the noise basically, or the water, if you were thinking about this as like a cylinder, from channel 3 would basically flood out and also impact everybody on channels 1 through 5, basically. And so like it kind of blocks out multiple channels within these blocks. And 2.4 gigahertz really just doesn't give us a lot of space, basically. And so this will increase your ping times, or the communication that's going from your driver station device to your robot itself, which is just kind of a generally speaking, not a great experience if it does end up happening to you. So if you switch over to 5 gigahertz, you yourself is going to have a better experience because there's many more channels that are available. I think there's something like 30 or something like that that are possible, and they're much further apart. So if you happen to be on, let's say it's like channel like 53, you're not going to be impacting as many people because the next usable channel is going to be too far away within the frequency band for it to kind of impact them, unlike with 2.4. So basically, to kind of sum all that up is if you're going to be utilizing a control hub, I would highly recommend using switching your Wi-Fi over to the 5 gigahertz band if you have a 5 gigahertz capable driver station device. We'll talk about that a little bit later and how to kind of do that just in a bit, but that's kind of the general there. One of the other huge improvements is that you don't have disconnections to your robot controller. The robot controller is now embedded inside of the control hub itself. So you no longer have to worry about those USB connections. You no longer have to go through a boot up process that is very, very regimented and the same, which is like keep your phone unplugged, keep the robot off, plug the phone in, turn on the robot, wait for this time frame. Like you no longer have to kind of do that type of song and dance, as it's not going to have that point of failure. The next one is actually its packaging for robots becomes a heck of a lot easier. So a lot of teams, like we'd go to events, right? And you would end up seeing teams are wanting to use the embedded camera that's on their cell phone. So on the robot controller itself. And you'd have this robot controller, the brain of their robot, probably the most important part of the robot itself to make sure that it's being communicated with. And it would be all the way on the front of the robot in harm's way, right? Like you could have somebody's, linear actuator could come through there, an arm, other robots, teams don't necessarily act maliciously, but things happen in the heat of competition where, you might not notice that your alliance partner is there and you bump them. So now you don't really need to worry about where you're placing your phone and making sure that you have like a 3D printed case, or you have like a case that you cut out of wood and have it in the right spot and have it protected, but still have access. You don't even have to worry about any of that anymore. You're able to use an external webcam. So you can use, for example, like Logitech has a number of webcams like the C270. And you could basically take that device and put it anywhere in your robot and just be able to attach it and go from there. So that's really kind of nice. The last one is actually kind of my personal favorite though, there's no longer a need to keep your phone charged. So I don't know if you've all had this experience, but I know from volunteering at events that you'd be sitting there helping a team as an FTA on a field, and they're running and everything is going great, and then all of a sudden 30 seconds a minute into the match the robot just dies, and you're trying to figure out why the robot dies, and you're able to say, well, it's not having any communication with the robot controller, and then you go and you check, and it's because the phone itself shut off because someone forgot to put the phone on a charger overnight and they were practicing all the night previous. And so you're no longer going to have these issues where your robot is just going to die mid-match because you're utilizing the same battery. Now, I mentioned this earlier as well. Since you are using the same battery, it does mean that you need to charge your batteries for your robot a little bit more frequently, and potentially you're not running them as far down as you were previously with an expansion hub and another Android device as your robot controller. So that's just one thing to kind of keep in mind, but it is kind of a nice feature. All right, so some of you have already probably gone through and done a transition to the Control Hub since you were part of the beta program last year. One of the things that I will say though is that there were a number of improvements that have been done. So if you haven't already, I would go ahead and update the operating system. We have 1.1.1. Is the latest operating system that is on the device. The original unit shipped with OS version 1.0.0. So we'll go through how to do that updating process. The FTC SDK that is running on those control hubs is likely a version 5.0 or later, somewhere in the 5.0, 5.1, 5.2, 5.3, or 5.4. Or maybe even 5.5 if you've actually updated your device. But if you haven't updated to the 6.0 version of the FTC SDK, I'd highly recommend doing that. There are a number of improvements that are in there that are Control Hub specific that will also help to kind of make sure that everything is kind of communicating. And then one of the other things as well is when you're kind of going through and utilizing the device is to make sure that you rename it and you set a new password. all the robot controller, or all the control hubs themselves, defaultly will have FTC dash and then a 4 randomly assigned sequence of letters and numbers. So that can be kind of difficult to find your team's thing inside of an event or even at your facility. I'm trying to find your own team's unit, especially if you have, like, let's say 2 teams that are operating out of the same shop. That can be a little bit difficult to find. But then secondly, especially on the password front, is the default password is just password. So having it where you're at an event and having anybody being able to get access to the device, it's probably not the most secure way to be operating. We're not going to assume that there's going to be people that are maliciously at events or things along those lines, but this way you can make sure that you're, one of the first areas is making sure that your stuff is secure. So setting a new password is a really good idea. And then also we go ahead and go about the process of connecting it to a driver station. A few selections that you need to make sure that you switch it over to be in the control hub mode versus in Wi-Fi direct. If you are trying to convert an old configuration file over, so if you have like a robot from either last season or 2 seasons, like last season, if you weren't a part of the original beta rollout in Romania, or from like 2 seasons ago that you all were looking at like having as like a demo robot and you wanted to use with the control hub, you will need to create a new configuration file. So basically it's a similar process of when you would have swapped an expansion hub. You kind of need to go into that and fix, and there's a fix option within the configuration menus. Or you can just create a brand new configuration because there is some things that are different with the control hub versus with previous things. It's mainly it's the addresses of what the expansion hubs are numbered and things along those lines. So just kind of keeping that in mind. And kind of with that, I could kind of show you guys a few things. So I actually have a control hub here and was planning on kind of running through a little bit of a initial bring up here. So we actually released a new piece of software called the Rev hardware client. So if you have a Windows machine, currently it's a Windows only piece of software. Hold on one second. Let me switch this to this screen. Here we go. Sure. Currently, this is a Windows only piece of software, the Rev hardware client. But this allows you to basically connect to devices. So you're able to connect to both expansion hubs and control hubs. You can also even connect to an Android device to be able to update the driver station that's on there. But for this process, we kind of want to run through what you're going to be doing with a control hub. So I powered onto my control hub and I have it connected via USB over to our PC. You can also use the hardware client if you're connected to its Wi-Fi network. Just be aware that if you're changing any of your Wi-Fi network settings, so basically if you're changing the name of the control hub or you're changing the password, that's basically going to impact the connectivity. So it will drop and need to reestablish a connection to the control hub with the new information, the new login credentials for that to work. It's part of the reason why I personally like when using the hardware client, like using it over USB, just because you don't end up having any of the issues with losing connections or anything along those lines. The hardware client itself is going to have this little update tab, which will show you what version you're currently running on these things and if they're up to date or not. If they're not already up to date, you'll be able to download and update them and move them forward. So with this control hub, it looks like everything that I have on here is already up to date, so we don't have to kind of go through that process. But the next thing that you're going to kind of want to do is you're going to want to go over here to the Program and Manage tab. Now, this window here is actually really, really similar to what you would get from basically connecting to the Wi-Fi network of the control hub and then logging in to it using its IP address through a web browser. So I don't remember the web address off the top of my head, but it's like 1.2.1.52. There's an 8080 in there somewhere. Anyway, it's in our documentation, which I'll show you guys in a second. But you're able to log into this Program and Manage tab through a web browser as well. So if you happen to not be using a Windows device, you will need to connect to the Wi-Fi network of the control hub to be able to do some of this in its current format. But in the future, we're working on getting the Rev hardware client to support other operating systems as well. So from here in the Program and Manage tab, so whether you're logged in over a web browser or you're using the hardware client, you're able to kind of head to Manage. And from here, this is where you're going to be able to see as well what versions you're running. You're able to update your Wi-Fi settings. So for here, we're using REV and then a string of numbers here at the end. For the First Tech Challenge program, I believe it's FTC followed by your team number is what the naming convention is. And then the password can be set to anything. So for this device, since we use it as for demos and things here, it's just set as password 1. But you can set that to anything that you can set that to anything that you would want your password to be itself, and then confirm it. And then here is where you're able to kind of choose your Wi-Fi band. So this device is already configured to 5 gigahertz, but if you do have a 5 gigahertz capable device, I would click on 5 gigahertz, and then you're able to select a channel to be able to move it to. So you can kind of select any of the channels that you want to go. And then once you click apply, it will end up going through the process of changing all the Wi-Fi settings that are on the device. Again, if you're connected to it via a web browser and using the Wi-Fi of the device, you'll have to reconnect using the new name and the new password, but that's fairly straightforward to do. Also, the other cool thing is that you can also update the firmware, the robot controller application, and the operating system all through the Manage tab. So if you don't happen to have the ability to utilize the Rev hardware client, this is also where you can kind of go to be able to update the device to make sure that you're running the most recent versions of the operating system and your robot controller application. If you are using Android Studio, you should download the newest version of the robot controller project, and then you can build and deploy the application onto the ControlHub through ADB. So either over a wired connection or there's wireless ADB as well. But anyway, so this is kind of where you're able to do most of those updates. The other cool thing too is you may, if you end up running into any issues with your ControlHub itself, you might be asked to send Rev some of your robot controller logs if you're running through our troubleshooting guide, and you can actually download them here, connect them to an email and zip them off to us. So that's another kind of cool thing because it can kind of help us see what exactly is happening with the device itself. One last really, really cool thing. So this is kind of not a part of the initial bring up process, but is a part of the Rev hardware client, is if you are someone who's using blocks or on-bot Java, you can actually download backup versions of the code now. So Android Studio users, a lot of them potentially had been using something like GitHub or Bitbucket or maybe even like Google Drive or Dropbox to try to manage their programs and being able to kind of manage that process of making sure that they have the most up-to-date versions of their application, their code. For blocks and on-bot Java, that kind of hasn't really existed. But now there is a way for you to be able to save backup versions of your code files and being able to use them at a later date. But yeah, so that pretty much goes over everything that we have with the hardware client itself. Last thing that I kind of wanted to show you guys though that I was mentioning is our documentation. So one of the big things that we know is like a lot of teams are meeting remotely, right? COVID is having an impact and is changing the way that a lot of teams meet. It's changing the way a lot of companies function. It's changed a lot of the ways that we function here at Rev, and it's having a large scale impact on how we all interact with First, right, and with each other. One of the really big things about that is it becomes a little bit more difficult for us to be able to help troubleshoot issues, right? Like it's a little bit easier when you have, let's say you have a team of like 8 students, right? And you have a mentor that you're all able to be physically there. And you're able to kind of go through things. And it kind of makes it difficult to be able to do that troubleshooting and other things. We've had documentation in the past that would be able to walk you through like how to get a ControlHub up and running, how to utilize our mechanical system and all these other different things. But we know that they were kind of hard to update. They were all versions of PDFs. So you need to make sure that you had the right version. And so you can end up having outdated information and things along those lines. One of the things that we did over the summer is we invested in changing over our documentation to a more virtual universe to be able to kind of help with basically the virtual nature that we're all going to be meeting in probably for a little bit longer. So in here, inside of our control system documentation, there's also a build system space. So docs.revrobotics.com is the main page. And then you're able to navigate to FTC through a number of areas there. You're able to go into our build system guides. You're able to go into our control system guide, our ControlHub guide. And then that's basically going to bring you into our control system from ControlHub. But it ends up having all the information, including some of it that I covered here. Like, for example, what are some of the dimensions and port power availability and other things around the ControlHub? You know, what cables and connectors do we end up using with the ControlHub, right? How do we end up using those connectors? But it also goes over things like, you know, we have the whole getting started thing and also a video with me, right? And you're able to kind of go through and getting connected to your robot controller console, like I mentioned. But there are also a couple of other things that are cool that are in here. So one of them, outside of just doing like the normal updating things, but one of them is actually troubleshooting your system. So like if you're running into problems with your ControlHub or with your robot at all, we have some general best practices for being able to run through and doing troubleshooting, but then also have some specific things like, so for example, like if you can't connect to your ControlHub's Wi-Fi, or your driver station is having issues connecting, or, you know, the status LED on your ControlHub isn't turning green, like, right, it's staying solid blue for a long period of time. We have some ways that we're able to kind of run through the troubleshooting for this. As there seems to be more kind of frequently asked or common issues that come up with that do have troubleshooting steps, we're going to be adding more things to this section to be able to make sure that you all have the tools that you're able to run through the troubleshooting without having to zip us an email, without having to try to get in contact with us here at Rev, because we know that teams, like, first off, teams are meeting at all different times. And specifically, like, for example, in your guys' case, being able to get a phone call from Romania to the US can not only be costly, but it also can be time intensive. So this way we're able to kind of be able to have more stuff that is available for you all to be able to go from there. We're also working on some intro stuff for programming. So like if you're specifically like this is a little bit more advanced, but if you're looking at using encoders, we have some encoder concepts in here, as well as like what the different encoder modes are in the SDK. And then one that I'm very happy with is with our sensors. So we're basically, if you have any questions about how to use sensors, what different types of sensors exist from Rev, what different sensors and how they operate with the ControlHub, there's more information that's in here, including being able to use sensors that maybe aren't 3.3 volt logic level devices, right? So all of Rev's sensors are all 3.3 volt operating, but there are some other sensors that are 5 volt that you might want to use. And especially for teams that are international, it might be a little bit easier to find a local supplier for for example, a potentiometer or a limit switch than it is to try to find a US vendor or being able to even get the items from Rev. Shipping is a large scale cost when it comes to running a lot of these teams. So we're trying to put out more resources that basically shows how to use Rev stuff with the things that you're able to find within your local community, whether that is electronics and technology, or if it's even like, corrugated plastic, if it's other raw materials that you have local to you, if it's plywood, et cetera, et cetera. We're trying to do a more concentrated effort to being able to make it where we have application examples, where we have the documentation that exists to be able to kind of go through and run through that process. So with that, let's kind of go back into here. There's a couple of other things that you kind of need to keep in mind with the ControlHub that are very ControlHub specific. One of the big ones is the radio. So with the robot controller phones, like if you're using an Android device, the radio is built in to that handset, basically. So wherever you put that on your robot, that's where your antenna was. With the ControlHub itself, it's built into the device, and it's approximately right here in this location on the ControlHub itself, on the internal of the device. one of the things to kind of keep in mind is just don't put like a battery or like really, really thick metal plate or something like that above the control hub itself. That is going to prevent the Wi-Fi connectivity from you having really low ping times, which then means it's basically faster communication with your driver station. And it may have a negative impact on robot performance. We have seen a couple of teams doing this with expansion hubs where they'll like Velcro the expansion hub on the top of the Velcro a battery on the top of their expansion hub. I would highly recommend not doing that with a control hub and just kind of keeping in mind where the radio is in general. Kind of last things, I know I'm kind of hampering on this, but use 5 gigahertz if you can, over 2.4. That's going to give you a much better experience. Try to use one that's 5 gigahertz compatible. If you don't already have one, for this season, I wouldn't be running out to go grab one because we're likely going to be running in a more remote setting. And if we do end up having events, they might be a little bit smaller. I don't know specifically what's going on in Romania with the events in your region, but like, for example, here in North Texas, I know that there aren't any real plans to be having in-person events until potentially early in 2021. If that is going, assuming that conditions are going to be there. The other thing that you kind of need to keep in mind is that your communication between the Android device, so basically your robot controller and the device IO, so your expansion hub, is going to be faster. So it is a direct serial connection. And basically through the updates in the operating system and through the robot controller itself, we've started to remove, basically there were some things that were in there that were set up to be able to make sure that that signals basically weren't lost. But if you happen to be using a control hub, you can basically kind of get rid of those more or less. So anyway, the communication speed is going to be quicker. So you're going to have more refresh rate on your control hub than you would on an expansion hub with a robot controller phone. And then lastly, and this one's actually really, really cool, is the control hub is multi-camera capable. So you do have 2 USB-A ports. And the FTC SDK does have support for multiple webcams, even in blocks now. So no matter what programming language you're using, you can end up having 2 cameras and being able to kind of switch between the 2. So if you happen to have a robot that has, like for example, this year's game, it may have an intake on one end to pick up rings, and then it has a shooter on the other end to shoot them out. And you want to be able to line up your shooter with a goal or something along those lines. Or you're locating off of the Vuforia targets, that would end up giving you a little bit more tricks in your toolbox, especially if your programmers have a little bit extra time in their hands and are looking for something fun to do. It does have the multiple camera support, which is kind of nice. But with that, I can kind of stop sharing right now, and we can kind of open it up to any questions that we have. That's basically it for the control hub, more or less.
Rugăm echipele să adreseze întrebări către Meg. În engleză, vă rog. Aici sau în formatul de chat. So, Meg, until they will send the questions. So what's the plan for the next meeting? So we discussed to have a second presentation with you in December 15. Same time. And will you present anything except answering questions or just answering questions?
So what we're going to kind of hope to do is it's going to be a little bit more freeform than this for the next time that we're going to do this. Is like what we're kind of hoping is that we're able to get a couple of questions from folks. Like if you're looking for something specific if you're looking for something specific, so we're able to kind of run through some application examples, or being able to kind of run through some specific answers to questions that may come up. So I know in the past we have done like some basics on basics on some robot design things, or like being able to point out some design tips on different things, being able to do things around programming. So what we're going to I do have some ideas on if there are no questions, but I was assuming that there was going to be some questions, which then means that we can kind of pull in some other resources here at Rev.
Indeed. Yes.
to make sure that we have the right engineers and the right folks involved to be able to answer more direct things. So being able to like showcase, like if there is a question on like I'm currently drawing a blank, but like if there is a question on like cool adaptations of using like linear motion, or if there's like programming examples that you're specifically looking on how to utilize like PID or something along those lines, we can be able to hopefully be able to pull in some folks to be able to give a little bit of an overview of how some of that stuff works.
Okay, we have apparently 3 questions by now. Is Emily there, or should you can read them in the chat?
Yeah. So I'm going to kind of take some of the easier questions first, just to kind of knock them out. Where you can find the Rev hardware client. So actually what I'm going to do is I'm going to go back and share my screen here really quick. So if we go into the Rev control system itself, so inside of our control system documentation, we do have the Rev hardware client page here. There is a download link that's available. You can also end up clicking over, and there is a full user's manual that's in here that shows like some of the things, like including updating and some things that we didn't necessarily cover, like for example, updating your expansion hub as well as connecting an Android device to it. So, and some things specifically around navigation and other things like that, some just cool tips that are there. But basically you can end up finding on the left-hand side here within our control system documentation, there is a link over to it. So docs.revrobotics.com, and then you can head to the control system docs and go from there. Another question that kind of came in here through chat, is it possible to use something like a USB hub in order to attach even more things to a control hub? So the answer to that, I believe, is yes. So the USB ports that are on the device put out, I think it's 5-volt power over USB. So it should be able to have enough power to pull in a connector, or like a USB hub. The one thing to kind of keep in mind is that you are going to be kind of there at some point, there is going to be a little bit of a power limit. So depending on how many things that you have plugged into it, and the power requirements of whatever device that you have plugged in, may sway kind of like what's going on with that individual port itself. Another question is, does the control hub have an internal gyro? Yep. So that is what the IMU is. So it's basically a 9-axis unit. So you will be able to get heading in the gyro from there. So you'll be able to do some of the similar things that you've been able to do with an expansion hub. A lot of the code should port directly over. So if you had like a pathfinding program that was if you had the same robot, you'd be able to just kind of drop that in, no problem. Another question that's in here is, can we read the current drawn by a motor? So basically being able to know if something is stalling, to be able to kind of cut power, and basically have that inside of your control loop itself. So with that, I actually don't know. I know that the availability for that has access in the firmware. I just don't know if the development was done on the robot controller side. And actually that would be a better question for our more technical folks that we have here at Rev on the software end. So we can definitely have that as something that we look into and be able to cover maybe a little bit more in depth next time. So at our time frame in December. So we have a question coming in from the YouTube video, or from the YouTube side. Where can I find some good programming documentation on Rev's ControlHub built in Gyro? Actually, this is, so there is sample code. So that actually does exist. So let me show, let me go to here. So I still have the Rev hardware client connected, but so if you go to, is this not? Hold on one second here. Let's stop the screen share and just let this share my screen instead, because that seems to be throwing some problems. Okay, there we go. So if you end up connecting to the device, you actually are able to see there's a sensor IMU sample code that will basically show you how you're able to get feedback from the IMU itself that is built in. So the other area that the sample code might be under is this BNO 055. So that's the specific chip that is actually inside of the control hub and also inside the expansion hub. You can also buy them separately as like a third-party thing through different suppliers. I know, like, for example, SparkFun is one here in the States that I know that sells a similar little thing. So that little piece will be on there. But basically this one will use it to be able to give you readings and feedback. We are actually working on inside of our documentation itself, trying to do some updates to the programming section. It's going to take us a little bit longer to be able to get those up and running, but with the end goal of having a pretty straightforward autonomous mode that would use both the encoders that are built into your motors as well as the IMU that is built into your control hub to be able to do a basic autonomous routine. Next question we have is, if we want to connect more devices than Expansion Hub has ports, do we use more expansion hubs or can we use regular USB hubs? So it depends on the type of device that you are looking at connecting. So if you want to connect more than 2 USB-based devices, then you will need to be utilizing a USB hub. The control, you cannot connect 2 control hubs together, basically. And the reason for this is that the Android devices that are built into the control hubs take control of the I/O that's below it. They would both broadcast their own network, and they're not going to communicate together. So there's no advantage to that. Also, it's technically illegal within the rules for FTC. And on the technology side, it's not really all that feasible. So if you're looking at using more than 2 USB devices, you would need to use a USB hub for that type of process. Now, if you're looking at using more motors or more servos or more sensors, that's kind of a different question and conversation. So you can utilize an additional expansion hub on top of the control hub. You can, I believe, from a technical perspective, connect more than 1 expansion hub going downstream. I know at one point we tested and had somewhere around like 12 or 15 of them set up at one point. But that's more of like the technical limitation of the system, more so than what is legal for the robot competition. I believe this year it's still 1 control hub and 1 expansion hub, but it's always best to check the FTC rules. I believe that's all in Game Manual Part 1, if I'm not mistaken. But yeah, so if you're looking at connecting more USB devices, you'll need a USB hub. If you're looking at connecting more motors or servos within whatever the legal limits are in FTC, that would necessitate either an additional expansion hub or some other communication board that you could utilize. Um, One other thing before I get to the next question. Kind of was showcasing here with the Rev hardware client how you're able to get access to some of the onboard programming. So whether it's blocks or on-bot Java, if your team is a blocks or on-bot Java team, that's a good way of being able to get access to it. Just know that we actually are aware there is a bug in the SDK that does not allow basically, it doesn't allow for variables to be created within blocks, which can be kind of a headache to some degree. We are aware of it, and we're working on getting a fix of it whenever the 6.1 version of the robot controller comes out. So just kind of keep that in mind while I remember that little tidbit. We have a question here. How is the SPM working? So that's the servo power module. So it's a separate little device from Rev. And how should we wire it to the control hub? The servo power module basically is a power injector. So what that basically means is the control hub itself. So the servo ports that are on there run at 5 volts of power. And the servo power module will run at 6 volts. The benefits of going to 6 volts, you're able to basically get, it's basically more power is going to, well, it's more voltage is going to your servo, which then ends up increasing basically the speed, the speed of the servo itself, as well as it will give it a little bit higher stall torque. It will give it a number of different other, positives at running at a higher voltage from a performance standpoint. And basically how it works is it passes along signal from the control hub itself or the expansion hub to the servo that you're operating. So you connect a PWM cable or a servo cable going from the control hub to the servo power module in the correct location, and then you connect your servo into the servo power module itself. And you need to have power going from the servo power module to the main power, wherever your power is within the within your robot. So if you happen to have an extra XT30 port that's available through a control hub or an expansion hub, typically I recommend just you take an XT30 cable and you cut it in the middle. You use this cut it in the middle or cut it close to one of the sides if you happen to have an extra XT30 cable laying around. And you can connect it straight into your control hub there. You will need to crimp on some connector. You'll need to crimp on connectors onto the end of the other end of the cable to then being able to connect onto the servo power module. There's some more information in the quick start guide for the servo power module that's on its product page that goes over what size terminals that you should use, using ring or fork, et cetera, et cetera. But that should be a really good, basically that should be a really good and easy way of being able to kind of get one of those set up. But typically if you're not using a number of devices that are using 12 volt power basically, or need to come off the main robot battery, you should just be able to pull that power straight from a control hub or expansion hub from one of the spare XT30 ports. If you happen to have other devices that are on those XT30 ports, like for example, a Blinken, you may want to use an XT30 power distribution block. So then you're able to kind of daisy chain power off from there. So there's kind of there. One other question that we kind of have in here is, do you think the Blinken LED driver has a significant enough power draw to impact overall robot performance? So from a power perspective, not really. LEDs are extremely efficient. It's running straight off your robot battery. Yes, is it a power draw, but it's nothing in comparison. Is it going to draw some power? Yes. In the grand scheme of your matches, is it really going to have an impact? Probably not. The larger thing that's going to be a much larger impact is how many motors you physically have on the device, just because the amount of power, like the inrush current of every motor, how much more power that they pull in is just going to be a lot higher. One of the things that is really useful with something like a Blinken is actually being able to know what state the robot is in. So inside of your code, this was a really, really clever implementation that I saw by a team at Houston Championship like 2 years ago. 2 years ago, they had a sensor. They were using a 2-meter distance sensor from Rev, but you could use any sensor. It could be a limit switch. It could be whatever. And they were using it to basically be able to detect how many minerals they had in their hopper, basically. And so the distance that it was reading was correlated to whether they had one object, two objects, or no objects inside of their hopper. And then the robot would change colors, whether it was green, yellow, or red, to let them know that now is time to go score. So especially if there was things that were in the way where you really couldn't see what was kind of going on with the hopper, having that type of feedback that is visual to a driver who's like physically looking at the robot can be quite useful. Is it 100% necessary? No. You can also achieve a lot of that through using telemetry data back to your driver station device, as an example. Or you just have like a very tall coach that's able to see everything. That also can kind of help work. So there's a couple of other ways you're able to get around it that's not technical, but it is kind of a cool device for those regards. When it comes to like events like First Global, we actually use the blinkins to help control LEDs all across the field. So being able to like light up different things and changing the states depending on the state of the game. So it's kind of a cool little fun device. I think I have time for a couple more questions before I gotta go. So if you guys have any more questions, you want to get those in chat, we can get those hopefully answered now. If not, we will be doing this again in a couple of weeks, early in December. Anna, I think, knows the better date on that. I have it on my calendar. I don't happen to remember off the top of my head, but we'll be answering some more questions there with some more technical, try to pull in some more technical expertise to be able to help answer any questions you might have about this year's game or using any of Rev's stuff.
If no more questions, we will finish. We'll finish